As with any model, the learning curve model also has its own set of limitations that we need to be familiar with when applying this model so that we know its shortcomings. So, first of all, we need to understand that conditions in the company will constantly be changing. And this means that it will be difficult to determine whether a learning environment is stable. And even if it is stable, it will be difficult to keep it stable for an extended period of time, which is required for the model to be realistically implemented. Furthermore, keeping track of all the data that is used to calculate the learning rate and all the other metrics will be difficult. Imagine that you have to record the time spent by workers on each unit or each batch, and then each subsequent unit and batch, and so on and so forth. And now imagine you're a huge company with many factories, hundreds of types of products, and you're recording the batches of production and units for all these different products. It'll be a hassle requiring lots of time, effort, and money. So that's an issue as well, right? Furthermore, you need to consider the fact that the whole calculation is kind of simplistic, wherein you rely on metrics like the time taken for the first unit or batch, and then applying a learning rate on that. And even if the learning rate or the time taken for the first unit or batch is slightly off, it could have a significant impact by the time you reach the calculation for, let's say, the 100th batch, right? And that would mean your whole analysis might become inaccurate. Furthermore, there's subjectivity involved in the estimates used to determine various different metrics in the calculation. For example, when will the steady state be reached? It'll be difficult to determine. Is it going to be at the 100th batch, the 200th batch, and so on and so forth. And as we know in real life, it's not necessarily going to be the case that you're going to continuously learn one batch after another and then you're going to stop learning. Sometimes you spend more time on a later on batch than you do on an earlier batch for whatever reason. Maybe you make a mistake or so on. Sometimes you reach a steady state, but then you find out something new that helps you learn even more. So the model itself necessarily has to take in some simplifying assumptions, which might not necessarily always be true in real life. And there's going to be some subjectivity involved there, right? And that also means that the learning rate, for example, might not be constant. So you would have, for example, situations where a worker is very good and he's very fast at learning, but then you might have a worker who's not that good and his learning rate is different. You can't apply a uniform learning rate across both workers. Even for one particular worker, maybe at some points they're very dedicated and hardworking. At those points they're learning faster. At other points they might not be as motivated and they might be learning slower, right? As a result, you need to consider all these factors when applying the learning curve model, and keep in mind, like with most models, it has certain simplifying assumptions, it has certain subjectivity, it has certain estimates, and it won't necessarily give you 100% accurate answer.